everyone, my name is Paul and today I would like to talk about a Houdini digital asset that I've been working on lately called PDG Asset Publish. Let's say we have the asset that appears in different lighting conditions on the show, and our production process for each light trick involves rendering the asset, converting the result into video, and publishing to a project management software like Shotgun for review. You may know there are many production management tools on the market, but Shotgun is pretty much the industry standard. Thanks to Procedural Dependency Graph or PDG, we can automate this process locally or on the farm without tedious coding. So here is the PDG asset publish. I'm gonna do a quick overview first and show you the example after. The UI contains the cook controls and tabs section. In the scheduler tab you can choose what scheduler to use with all the settings. Currently there are two available, local and HQ. In the lighting tab you can specify the path to one or multiple light rigs and optionally the path to the HDRI or image that represents the HDRI from the light rig. This image will be used later for compositing purposes. In the Render tab, you can choose the render engine and adjust the render settings. Currently we have OpenGL, Mantra and Karma. All the engines except Mantra can render lobes. The other tabs are optional and can be enabled from the cook controls by toggles. In the Com tab you can enable frame timecode, also HDRI that you previously specified in the lighting tab, plus gray and chrome balls overlay if you render lobes. In the video tab we can change some FFmpeg settings, and in the Shotgun tab the shotgun related settings. I'll be using this spaceship asset example to clarify things up. It's a turntable with 4 light rigs: day, overcast, sunset, and night. Each light rig is located in its own subnet and defined by the subnet's name. As you could see, the PDG asset publish is a SOP level HDA. We are gonna use the local scheduler to test it and one light rig for now, sunset for example. In the render tab we will be using OpenGL, and as you may know it's a GPU render. We have to specify the asset with global path. Frame range, I like the frame 25 and the camera path is correct. I'm okay with the output file image name. Just keep in mind that the render type and light rig names will be added to the file base name. In this case I expect to see beauty_sunset.0025.exr. In the display options I would change the anti-alias to something more reasonable. More light samples, ambient occlusion, reflection, and click cook. Okay, it's ready. In the render folder, as we can see, the image file with output image base name plus render type name and light rig name. Let's add the frame code text at the bottom of our render and the light rig HDRI icon at the left top corner. To do that we have to set the image file path under the lighting tab. Also enable the compositing tab and make sure that the frames and HDRI icon are enabled. In the frames tab we can change font type, text, and text size. In the HDRI tab, padding, image fraction, it means from the actual render frame resolution. Also font type and the size of the image file name text that will be shown at the bottom of the icon. The output file name will be comp plus render type and the light rig name. Click Cook, and only the compositing operations will be calculated. OK, done. And as you can see, a new image file has been generated with the frame code and HDRI. I'm pretty happy with the result, and I think it's time to render all the frames and convert to video. Let's jump into Render tab, and in this case all frames in one batch must be enabled. Otherwise all the frames will run concurrently, and this may hang Houdini or your system. Plus, it's not recommended to run multiple frames in parallel with GL anyways. Also, we have to enable the Video tab and make sure that FFmpeg has been installed. You can download it from the ffmpeg.org website. Download, Windows, Release. After downloading, you can unpack and put all three executables into C Windows System32 folder. It has to be done if the FFmpeg binary parameter is set to system path. In this example, we are gonna use a custom path to the binary files. Click Cook, and the video file will be generated. Here is the video file. OK, cool. It's time to submit this file to the Shotgun. But to make it work, we have to download the Shotgun API from this website. Then unpack it and copy shotgun_API 3 folder to Python 27 lib site packages located in the Houdini installation folder. OK, we're all set. Now we have to enable the Shotgun tab, and I'm using a JSON file to access my project page. Also, we can choose to use the login and password, but it's not recommended due to potential exposure of your credentials in the environment. It can be a security risk. This is my Shotgun page, and my project name is PDG demo. The asset name is ship, and the version name is ship v1. Let's click Cook. Alright, we've got the asset published to the Shotgun. Let's check this out. My page, PDG demo, assets, ship, ship v1, plus OpenGL, and the Lightrix name Sunset has been added to the version name. Beautiful. Let's publish all the Lightrix simultaneously. In the Render tab, we switch source to LOPS and specify the ship LOP network path. This is how it looks. All the Lightrix are under the Lights primitive, and each of them is located under its own unique name. I would like to overwrite the existing files by switching the cache mode to Write Files. It would make sense to set frame per batch to 25 to avoid overhead, since GL renders are generally fast. Camera and render settings are fine. Same in the Comp tab. As you could see, we've got the additional tab called Balls, which enables the gray and chrome ball overlay on the right top corner of the rendered image. This is only accessible when rendering LOPs. We can copy camera rotation and paste it into Rotate Camera parameter to match the camera angle. In the Video tab, we are switching to Write Files, and the Shotgun tab we have to enable version only. This will publish all the clips to the ship asset if it exists. Scheduler tab. If we use local, we have to enable single in the job arms to avoid rendering all the light rigs in parallel. But I like to use HQ Scheduler to utilize my home farm. We have to specify the HQ server address with a default TCP port of 5000. And in the Job Farms tab, tasks set to single. This means that each machine can run only one job. It's critical with GL, otherwise we may get VRAM overflows. In the Lighting tab we add 3 more light rigs and change the name to lob style path. Also copy-paste the HDRI path. Click Cook. Okay, as we can see, it's all in the shotgun now. Awesome, it's karma time. We can remove the single tag. The number of the concurrent jobs that each machine can run, we can control with the CPUs per job and Houdini max threads parameters. But in my case I have these settings set per each machine in its hqnode.ini file. You can learn more about it in the Houdini docs. In the render tab we switch to karma. The lob path is correct. 10 frames per batch. Camera and render settings are fine. We can override that render settings with the settings from the lob network by enabling the render settings prim parameter and defining the render settings primitive from the lob network. Comp, video and shotgun settings are fine, and click Cook. And we can monitor the rendering process with HQ web service. Okay, it's done. Let's check the shotgun. I think it's looking good. Same thing with Mantra. We need to change in the Lighting tab the path for each light rig to OBJ, and in the Render tab choose Mantra and the candidate object. Render settings are fine, and click Cook. Let's check the shotgun page. Alright, it's looking good. Okay, it's time to dive into HDA and check what's inside. This wage generates the tasks based on the number of the light rigs. The Python script isolates the HDRI and light rig names from the path. The attribute create generates the render attribute based on the selected render type. These nodes create important attributes like camera and frame range. The wedge node generates tasks for the chrome and gray balls, plus related attributes. These nodes are responsible for the rendering tasks. And these nodes combine balls output with actual render results per each light rig. Here is the compositing part. After that we have the video encoding, and then the shotgun polishing. It's important to note, if we already have rendered files on disk, and cache mode in the render tab is set to automatic. The PDG won't overwrite the existing files, even if we change the render settings. This is true for all the render types as well as comp and video tabs. This issue will probably be addressed in future builds of Houdini, but for now we can use the write files cache mode. Also, it's worth to note that the ship in Lobs GL looks different from the standard GL viewport. Let's compare it using a memory toolbar. And as you can see, it's much noisier and more reflective than the standard GL viewport. This is happening because of the USD preview shader doesn't support specular roughness texture in the Lobs GL viewport, and whole surface gets specular roughness value of 1. Currently there is no fix for it. Another issue that we may see is when the glass disappears in the GL viewport if we switch the transparency from low to medium or high quality in the display options. But it looks fine in headlight mode. To fix this, we have to set the transparency of the shader to 0.99 instead of 1. And it's fine now. There are a few new PDG features that are worth mentioning. In the performance monitor, we can see more detailed TOPS feedback than before. Also, the collapse and show log summary. The last one is handy for troubleshooting things. The asset is open for an expansion. It's pretty easy to add other hider render delegates. Here's an example for Peerman integration. It's just a matter of dropping the render settings node over here and promoting its parameters to the HDA UI under the render tab, plus adding a menu item to the type parameter, and make sure that the render name is exactly the same as we would see in the drop-down menu of the other delegate parameter on the USD render node. And the last step is to add the render delegate name to the attribute create node render parameter, like that. Also, there is a possibility to add deadline and tractor render schedulers to the asset. This can be done by dropping the render scheduler node and promoting the attributes to the scheduler UI tab over here, and adding the name of the node to the drop-down menu of the top scheduler parameter. The name of the deadline scheduler node should match the token value of the menu item. Alright, this is pretty much it. So I hope this presentation helps to understand how useful and powerful PDG is in automation of the everyday CG production tasks. I would like to thank all the amazing side effects developers for making this little project possible. And special thanks to Fiona Wong for giving me this opportunity. I hope this tool will make your life more productive and efficient than before. Feel free to contact me if you have any issues or questions related to the HDA at pdg.asset.publish@gmail.com. Enjoy and happy asset publishing!